Let's say they give you this diagram of a boat of mass 200 kilograms on water, and the question says, the boat is initially at rest, but due to wind, the boat is traveling at 6 meters per second 2 seconds later. And they ask you, what is the force due to the wind? Could you answer? If not, continue watching this video. So, to start off, to solve this question, we need to apply Newton's second law, which is the summation of force is equal to mass times acceleration. Summation of forces is just the net force, and the acceleration is the acceleration due to this net force. And we can break this down into components where we have Newton's second law in the x and the y direction. So if we bring this back to our example, we can start off by drawing a free body diagram, which we just have to identify all the forces acting on the object, which we have the normal force, the weight force, and the force of wind. And we can draw a coordinate system, which in this situation, the x and y makes the most sense. Note that we have forces in the x and in the y direction. So we can start off with the summation of forces in the y equation. In the y direction, we have the normal and the weight force, so we plug those in, noting that weight is negative because it's in the negative direction. We can assume that the object is not moving in the y direction. Since it's not moving in the y direction, the acceleration in the y is going to be equal to 0. So if we plug that in, we get this expression here. Then if you remember, weight is equal to mass times gravity, you plug that in, and then we get this for the final answer for the normal force. So that just means that the net force is going to be equal to the weight force. That force on the object is going to be 0 in the y direction, which makes sense since there's no motion in the y direction. Now we can look at the x direction. So if we start with our Newton's second law equation in the x direction, and then we can look back at our free body diagram and note that the force of wind is the only force acting on the object in the x direction. So we can plug that in, and then we can identify that the mass is equal to 200 kilograms. But if we look at this equation, we have two unknowns, the acceleration and the force of wind. So if we remember our kinematics equation for the velocity here, we can find the acceleration using this. We just have to identify a couple of variables here. So in the question, it says the boat starts at rest. So that means the initial velocity is equal to 0. And it also says that t equals 2 seconds. The velocity is 6 meters per second. We use these variables and we plug them in. We get this expression here. And then we can isolate for the acceleration by multiplying both sides by 1/2 seconds. Divide the amplitudes into units, and we get this for the final answer. It's the acceleration of the boat due to the force of wind. Plug this back into our Newton's second law in the x direction equation. Plug in the force of wind, our mass, and the acceleration we just found. And then if we do the multiplication, we get 600 newtons for the final answer. So this is the force of wind that causes the boat to travel at 6 meters per second 2 seconds later. We can see that in the diagram below. We have the boat at t equals 0 seconds, and we have the force of wind, 600 newtons. And then 2 seconds later, the acceleration is 3 meters per second squared, the velocity is 6 meters per second, and the force of wind is still 600 newtons. This is neglecting the friction between the water and the boat. If there was friction, the acceleration would be smaller because the net force would be smaller.